Today we're going to look at volumes of prisms and cylinders. So the volume of any prism is the area of the constant cross-section of the prism multiplied by the perpendicular height of the prism. So if here we've got a triangular prism, the constant cross-section is the cross-section that if we were to cut all the way through it in the same parallel manner, that we'll get the same shape each time. So here you can see the triangle's the same on the front and the back. So if we were to cut through at this angle all the way through our triangular prism here, we get the same triangle shape all the way through. So the area of the constant cross-section is that area of that front face, that triangle, the triangle that occurs all the way through our prism. So if we multiply that area, that cross-sectional area, multiplied by the height of our prism, we'll get the volume. And once again, this is looking at volume being a third dimension to area, or the third dimension, and area being second dimension, 2 dimension. So here we're looking not just at length times width, at the area, at a 2-dimensional plane, but we're then extending it down to a third dimension. So here, the volume, the area is in a square unit, so a square unit, multiplying it by another length unit, we get a cubed unit, a cubic unit with three dimensions. So just as an example, we're looking at a few different types of prisms. Here we've got a trapezoidal prism. It's called that because it's got a trapezoid as its cross-section. So if we were to cut through any length along here, any length along our trapezoidal prism, we would get the same trapezoidal shape. We could turn it around and see the same trapezoidal shape on the rear of our prism. So the volume is equal to the area, that cross-sectional area multiplied by the height of our trapezoidal prism. So this is our area here, and the height is our extending that face into a third dimension. So stretching it out into a third dimension. So the area, the formula for area here, if we've got this top dimension of our trapezoid is A, this is B, and the height of our trapezoid here is C, and the height, or the length, the width, depth, whatever, of our prism is recognised as H here. It's the area times H. So the area of a trapezoid is given by this rule, 1/2 times A, this top side, plus B, all multiplied by C, the perpendicular height of the trapezoid there. And we multiply all of that area by H. So this H here just carries down, and this whole thing here, this whole thing is the area. That's all the area there of that trapezoid. Looking at the cylinder here, we've got the radius of the circle end of the cylinder, and we've got the height of the cylinder here. So the cross-sectional area is going to be this face at the end, and we've got the radius of that end there. So the volume of our cylinder is going to be the area times that height, that perpendicular height of our cylinder. Once again, looking at our cylinder as a prism, slicing through all the way along the height of our cylinder, we will get the same circle each time. So volume is the area times the height. The area of our circle at the end there is going to be pi r squared. So the area of our circle, pi r squared times the height. And that's going to be, that carries down directly, and that's the area there of our circle. Looking at some examples now. First example, we've got to find the volumes of these prisms. Here we've got some sort of prism. We've got given the area of 10 centimeters squared, and the height is 3 centimeters squared. So the volume is the area times the height. So that's 10 centimeters squared times 3 centimeters height. So that's 30 cubic centimeters. 30 cubic centimeters in volume. Looking at this second prism here, we've got a triangular prism. The perpendicular height of the triangle is 2 meters, the base of the triangle is 4 meters, and the height of our actual prism is 8 meters. So volume is area times height. So we've got the area of the triangle is a half base times height. So don't get confused with these height. This is our triangle here, and that's the height of our prism there. So the base of our triangle is 4 meters, the height of our triangle is 2 meters, and the height of our prism is 8 meters. So here we've got 1/2 times 4 times 2 times 8, and that's equal to 32 cubic meters. 32 cubic metres. Our last example, find the volumes of these cylinders rounding to 2 decimal places. So for our first cylinder here, we've got a radius of 2 centimetres there marked on our cylinder, and the height of the prism, the height of the cylinder is 10 centimetres. So volume is area times height, so it's pi r squared times height. Our radius is 2 and our height is 10. So plugging that into our calculator, we get 125.6637, and we're asked to round to 2 decimal places. So looking at this is the second decimal place. Looking at the number to the right-hand side of it, it's not big enough to round up, so the answer is going to be 125.66 cubic centimetres. For our second cylinder here, we've been given the height of the cylinder as 20 metres, but we don't have the radius, we've got the diameter. So the radius is going to be one half of the diameter there. So to work out the radius equals the diameter divided by 2. So it's going to be 14, which is the diameter divided by 2, so it's 7 metres. So that the radius of our circle at the end of our cylinder is going to be 7 metres. So once again, volume equals area times height. The area is pi r squared times the height of the prism. R is 7 and height is 20. So that gives 3078.7608, and many more decimal points continuing on there. But we've been asked to round to the second decimal point. To the right of it is not high enough to round it up, so we're going to keep it as it is. So the rounded answer is 3078.76 cubic metres.